Okay, we're looking at writing equations and solving equations. We're going to start with section 5, just about solving equations, how you can use the number properties to help solve equations. First, we're going to do a quick review. You remember this is something that you can skip over if you want to save yourself a little time. However, it has value. It will refresh your memory on some of this stuff. For each of the following equations, find a number x which makes the statement a true statement. So obviously, if I put a 0 in here, it would not be true. What could I put in there that would make it true? X equals 2 would make that true, wouldn't it? How about this one? What would make this statement true? If I put in a 0, it certainly wouldn't be true. If I put in a negative number, it certainly wouldn't be true. I know it's got to be a positive number. What times 3 will equal 12? And how about this one? What would make this one true? What number could we divide by 5 and get 5? Clearly, it has to be larger than 5, doesn't it? Now, you probably already figured out what that should be. But suppose I just wanted to solve this using methods I learned in Algebra 1. If I were to multiply both sides of this equation by the same number, that's okay, right? As long as I do it to both sides of the equation, I'll have 5 over 5, and 5 over 5 is equal to 1. So I'll have x equals 5 times 5, 25. Let's evaluate this for this expression. Notice we don't have an equation here. This expression for x when x is 3, that would give us 12 plus 7. So the value of this expression when x equals 3, 19. How about this one? What is the value of this expression when x equals 4? Well, it's going to be 3 times, if x is 4 and we add 1 to it, that'll be equivalent to 15. How about simplifying this expression? Well, let's start right here. I know that 8 over 8 is equal to 1, so this very first term is 1. And what happens here? I've got 7 over 7, which is equal to 1, and 3 over negative 3, which is equal to negative 1. So I end up with 1 plus a negative 1, or that would otherwise be known as 0. Okay, a little refresher for us. Solving equations, we've been looking at the properties of numbers. Commutative, a number can change its position, commute, and that can be done in addition, that can be done in multiplication. Associative, you can regroup them. It doesn't change the value. Again, addition and multiplication. Distributive function or property, just saying that we can multiply across addition. And similarly, if we have a common factor in terms that are being added, we can factor it out and go this way. Identities. The identity for addition is 0. The identity for multiplication is 1. So we can add 0 and something keeps its identity. We can multiply by 1 and it will keep its identity. Inverses. For addition, we talk about using the opposite sign. And For multiplication, we talk about taking the reciprocal or flip that fraction. All right, that's what we're talking. Oh, my handwriting. Good grief. My handwriting is actually pretty good. You'd never know it. Now we will look at properties of equality. What does the addition property of equality say? Ooh. Okay, so back up here we got properties of numbers. They're all right here. Now we're going to talk about properties of equality. So this would be things that apply when we're working with equals or equations. Equations are statements that one thing is equal to another. The addition property of equality says, I'm listening. Whatever I add to one side, I can also add to the other, right? What does the multiplication property of equality say? Very similar, right? As long as I multiply both sides by the same number, it will stay equal. There are different ways to solve an equation, but you're only going to have one solution set. There may be more than one solution. Notice the big word here is set, one solution set. Is 3 a member of the solution set for this? Well, how could we test that? We put 3 in there and see if it results in 0. Yes. Suppose x is equal to y. In that case, does x times 17 equal y times 17? Yes, it certainly does. Does x minus 17 equal y minus 17? Yes, it does. Does x times x equal y times y? It certainly does. X times x equal y times z? What? Trying to trick us? No. What's the trap in this little equation? Well, we've got 3x minus, I'm just going to apply the commutative property of addition, and I'm changing the position of these two. They're going to swap positions. It's still equal. What's going to happen here? If we associate these two, that's right, they're going to zero out. We will have our x's disappearing here. Let's use the addition and multiplication properties. So this is going to be a little different than what we did back at the beginning. Remember right here, we just looked at it and we could tell. Now we're going to be a little more formal about it. And we're going to make sure we use these properties and we state what properties we're using. So we're going to start with, on this first one, using the addition property. I am going to add, think about it that way, I'm going to add a negative 13 to both sides. And when I do this, I end up with 6x equals 14, don't I? Now I use the addition property. I added the same thing to both sides. Multiplication property, multiply by the same thing. Well, here I'm going to use the inverse, multiplicative inverse, also known as the reciprocal, of 6. I'm going to multiply both sides by 1/6. I'll have x equals 14 divided by 6, which should simplify, right? You should always simplify your answer as far as you can. The second one, We're going to start by using the addition property, and this time I'm going to add a positive 3 to both sides. Then I'll have negative 4x. This will zero out, equals 10. And now I am going to take the reciprocal, the multiplicative inverse of negative 4, which is negative 1/4. I know you're probably thinking, okay, you're just dividing by 4. Well, dividing by negative 4. True, that's what I'm doing. I'm dividing by negative 4. But I like to think about it as the multiplicative inverse. Words are so much more, blah, 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 you know, more syllables. It's more fun. Like bamboozle is more fun to say than fool, right? So multiplicative inverse, I can barely say it myself. When I multiply these together, I get a positive, don't I? And in fact, a positive 1. So I'll have x equals, and over here I have a negative. Negative 10/4, which is equal to negative 5/2. This one's a little more interesting. I'm going to start with the addition property. I am going to add 2x to both sides. Positive 2x added to both sides. The other thing I want to do, because what am I aiming at here? Whenever we're solving an equation, at least a linear equation, try to isolate that x. Get that all to one side. So we don't want this 6 added to it. So what will I do? I will add a negative 6. What I do to one side, I always do to the other. That's the addition property of equality. So these will stay equal. These will zero out. I'll get a 0 out of this, 0. And I'll get a 0 out of this. I'll be left with a negative 9x on this side. And over here, I'll have a 36. Oh, I'm liking the looks of this. Now I'm going to take the reciprocal of negative 9, which is negative 1/9. I'm going to multiply both sides by that. You know, up here I should have put parentheses around that too. The danger of not putting parentheses around something that's got a negative on it, if you get distracted for a moment and you come back and look at it, what does it look like? It looks like you're doing a subtraction. But if I put the parentheses around it, it makes it very clear that that's a multiplication. Now I stepped away from this, so it'd be very easy for me to forget the multiplication property of equality. This needs to be done to both sides. So quick, before I forget it. It's a problem with interruptions. A lot of mistakes happen because of interruptions. Very dangerous. A negative and a negative, positive. 9 divided by 9, so I get a positive 1x. And a negative 4 on this side. Very nice. Now this one, before I do any of the properties of equality, I think I will try to simplify both sides. This side is already looking about as simple as you could get it. Those are unlike terms. I can't combine them. But over here, I have like terms. They have the same variable at the same exponent. So that would become 5y, wouldn't it? Plus 3. Now that I've simplified the sides, let's try isolating the y's all to one side, which means I'm going to add a negative 5y And in order to get this free of anything being subtracted from it, I'm going to add a positive 5. Again, I'm using this property of equality, the addition property of equality to do this. What happens here? These will zero out. When you add something with the opposite sign, it will zero out, leaving me with 10y equals 8. Oh, this is nice. All positives. Now what? I'm going to multiply both sides by the same number. And the number that makes sense here? Of course, the multiplicative inverse. 1/10. Now you don't have to talk about the multiplicative inverse. If you want to keep thinking about it as I'm dividing by 10, that's okay. As long as you understand what I say when I say multiplicative inverse. We'll be talking the same language, and you can do it in the way that makes the most sense to you. Remember to simplify. We're going to move right on to writing equations. Now this is going to be word problems. Oh, I have a little cartoon here by Gary Larson. How much wood would a woodchuck chuck if a woodchuck could chuck wood? All right, so this looks like an interesting mathematical problem. When you figure it out, let me know. When we're solving algebraic problems, for that matter, let's talk about any problem, even the problem of where am I going to go to school next year? Well, I hope it's going to be St. Thomas. If you're a senior, you'll be thinking of something else. Understand the problem. Good place to start. Understand what's being asked. I hate to tell you how many times I've looked at tests and quizzes where students do beautiful work, but they don't answer the question that was asked. So then, once you understand what's being asked for, figure out a plan, then you go through and you find the answer. But I would actually, this comes out of your book. They have a 3-step process for some reason, but isn't this a 4th step, and shouldn't we think it was important enough to make it its own? Check. I like to do it this way. Say, does it make sense? That's always a good question to ask. That will save you embarrassment in your future. I guarantee that. And I'm not talking about school. I'm talking about when you're out working. Okay. Here's your book's method. It's really a good guideline. So you might want to take a look at your book. Phase 1, understand the problem. Phase 2, plan your response. Find an answer. And does it make sense? Okay, let's try a couple. 31 is 9 more. So 31 is larger, right? 31 is 9 more than twice a number. So what are we looking for here? I'd say we're looking for, what is that number? Let's find that number. We'll say n is the number we want, okay? And let's try writing an equation. Anytime you see is, think equals. So we've got 31 equals, we've got twice a number, so 2n, and 9 more than that. So that means we have to add 9 to that. How does that look? So we understand the problem is that we want to find this number. Our plan is to use algebra, and we've written out an equation. This looks like a good plan. Let's see. Let's check that. 31 is 9 more, plus 9 is 9 more, than twice that number, sure. Now we can go ahead and find our answer. We're going to use the properties of equality here, which means I'm going to start with the addition property of equality. I'm going to add a negative 9 to both sides. That will bring me to 2n is equal to 22. Sound good? And then I'm going to use the multiplication property of equality, which says as long as I multiply both sides by the same number, that's going to be the multiplicative inverse, otherwise known as the reciprocal of 2. I know you're saying, oh, Mrs. Turner, we're simply dividing by 2. Stop your big words. Okay, so we've got n equals 11. We found an answer. Now, does it make sense? 11. Okay, let's try it. 31 is 9 more than twice 11. Well, twice 11 would be 22. 31 is 9 more than 22. So, check. Looks good. Here's another one. The final exam in a course will count as 30% of the total course grade. Well, that's quite a bit. I mean, we don't do that, do we? We say it's worth 10%. Okay. Prior to the final, 245 points are possible. So prior to that, we had 245 points. How many points will the final be worth? Oh, well, let's say x. That makes some sense too for exam. X equals the number of points in final. Now that's the total number of points that could be achieved. Okay, so I've got, how can I put this into an equality? The final course in an exam will be 30% of the total. Well, let's figure out what the total is. How can we write that algebraically? We don't actually know what it is, do we? We know that it's 245 points before we take the exam. So after we take the exam, it's going to be 245 plus x. Now somehow I've got to work this 30% in, don't I? Oh, I think I see it. So the number of points in the final, if we took the number of points in the final exam, I guarantee you my handwriting's better than this. I'm sorry about this. And we divided that by the total, that would give us the percentage, right? The percentage of the exam in the total course grade. So we can put this into an equation, right? We know that the number of points in the final are x, and we know that the total is 245 plus x, and we know, because we're told here, that that's 30% of the grade. I'm not going to put 30%. Never put the percent in. Well, as soon as I say that, there'll probably be something that we do, but I can't even think of an instance right now. So we're going to always write that in decimal. 0.3. Oh yes, I could write 0.30, but we know that's 30%. How am I going to figure this out? Well, I could look at this and say, I know I've got a proportion, so when I have two fractions that are equal to each other, I can cross multiply. Remember that? So I'll end up with x equals 0.3 245 plus x. Oh, this is going to give us a great opportunity to use the distributive property of numbers. Remember that? Oh, this is great. So we're going to work on simplifying this side. We have to get this x out of these parentheses. It's trapped in there right now. We got to get it out. X equals, oh, I am going to need a calculator here, aren't I? Let's see if I have a calculator that will work. How's this? Cool? Let's see if I can turn it on. Oh, good. Let's see. We'll say 0.3 times 245. Okay, so I get a 73. Oh, it disappeared from view. That's not good. 73.5 plus 0.3x. I want all my x's on one side. This is very good, by the way. I did get my x out of parentheses. Let's move down a little bit. I'm going to use the addition property of equality, which says as long as I add exactly the same thing to both sides, it stays equal. So I'm going to add a negative 0.3x to both sides. So what will I have here then? I'll have a positive 0.7x equals 73.5. I think I need my calculator. Now I'm going to say, okay, I've got 73.5. I want to divide that by 0.7. Right? Or what did I say previously? I'd say we'd take the multiplicative inverse of this. All right. I'm going to get simple here. We're just going to divide by 0.7. Let's see what we get for an answer. It better be an even number, because I know if I'm a teacher, I do not want... Ah! Right. The points 100 and x equals 105 points. All right, does this make sense? Does 105 look like it's about 30%? It'd be less than a third, right? A third would be 33%. It looks about right. So does it make sense? Yeah, looks pretty good. I knew it was going to be less than 30%. Oh, yeah. It's so tricky to think about, isn't it? Because the total points in the class are apparently 350. 30% of 350. Yeah, that looks just about right. Very good. I love this stuff. How about you? I know the big deal is, do we have time? It's always time, that factor of time. We have one more. I like this. It's a word problem. The Acme Widget Company. I love this company. It shows up all through mathematics. Of course, there is no such company, but anyway. we've got $13,000 available for our project of making widgets. Part of the money has to be spent on an advanced widget bending machine, which costs $1,000. This is so typical. You know, I come out of manufacturing. It always costs money to make things. You have to be willing to make some capital investment. Okay, so the manufacturing cost for each widget is $3. So it cost me $3 to make this. How many widgets can be made with the money that I have? So I want to make up some inventory and then we'll go and sell them. But I'm restricted to this. Okay, so I got a total of $13,000. That's my total. And out of that total, I am going to have $1,000 that I have to buy the machine, and then $3 for each widget. So if I say W, I want to know how many widgets. W equals the number of widgets. Maybe my handwriting is getting better. Now I can figure it out. I subtract using, what is that property? That's right, the addition property of equality. I subtract 1,000 from both sides. So I get 12,000 there, and of course that zeros. How many widgets can I make? I'm going to divide both sides by 3. I can make 4,000 widgets. Hey, nice job. You hung in there with me. You don't know how much I appreciate that. Now, you also have to be taking a look at, gee, I skipped around a little bit here. You have to look at sections 10 and 11. So that's a separate video.